So, in this session, we will continue our legacy of organic named reaction series. And as you all know that I have already completed 20, 28 name reactions on my YouTube channel alphabetically. Okay, so you can go and check in the playlist of my channel. Okay, and now today we will discuss the Oxy-Cope rearrangement. Okay, we have already discussed Cope rearrangement and anionic Oxy-Cope rearrangement, but today in this session we will discuss Oxy-Cope rearrangement. Okay, so what do I mean by oxy? Why not here? Why not here anionic oxy? Because here in this region, here in this region we have only taken as a heat. There is no base we have taken. Okay, there is no base. There is no base region in this reaction. So that's why the reaction name is only Oxy-Cope rearrangement. Why it's oxy? Because there is a hydroxyl group is attached in this substrate. That's why we are calling this Oxy-Cope rearrangement. And what is a cope? So cope is just a scientist name who discovered this reaction. That's all. And in this reaction, the mechanism will be followed is a 3,3 sigmatropic rearrangement. By this mechanism, by this sigmatropic reaction, you will get your product. Okay. So basically, I am trying to say the name oxy is given due to this OH group is attached in this case. Okay. And also some people can ask what is the difference between the Oxy-Cope rearrangement and anionic Oxy-Cope rearrangement. Anionic Oxy-Cope rearrangement and Oxy-Cope. Okay, so the difference is very basic. Okay, anionic means the OH is now converted to O minus. Okay, oxy means only OH, right? So this is the basic difference. You can also visualize, you can also think behind this name oxy and anionic oxy. When the anionic oxy form, when we take a base in the region, then we say that reaction is anionic Oxy-Cope rearrangement. Okay, when we not take a base, when we didn't take a base, then that is called simple only Oxy-Cope. Because in this reaction we are not taking any base, so that's why there we call only Oxy-Cope rearrangement. Okay, so now let's start the mechanism. How this substrate is converted into product. Okay, so now let's start the mechanism, right? Okay, so my substrate is something like this. Here is a double bond here, and something like this, double bond here, and you have here hydroxyl group attached. Is OH group is attached here, and here is the R is the alkyl group is attached, and now you have a heat here. Okay, so one more thing, the one more difference is in the anionic. Let me write very clear because this is very important. You have to understand. Okay, okay. So here is anionic Oxy-Cope, and in this side I am writing here Oxy-Cope, right? So what is the basic difference is, in the anionic Oxy-Cope we take the low temperature, the reaction condition, low temperature. But in the case of Oxy-Cope we take the high temperature. Okay, and in the anionic Oxy-Cope we take a base. We take a base in the reagent. But in the case of Oxy-Cope we are just only giving a heat, no any other base, no base we take. Okay, so this is the basic difference between the anionic Oxy-Cope and Oxy-Cope, right? You have to understand the difference, the basic difference, why these are the two names, anionic Oxy-Cope and the Oxy-Cope. But in this session we are going to discuss only Oxy-Cope. Okay, so now let's go to the mechanism. So we are taking here, let me erase this, okay, because I have a less space here, so I have to erase. Okay, let me erase. sorry, yeah, yeah, okay, fine. Okay, so we are taking here heat. Heat means uh, the range of a heat is 150 degrees Celsius to 260 degrees Celsius. We can take here is the heat. Okay, so as you all know that because there the mechanism is a 3-3 sigma tropic. Okay, 3-3 sigma tropic, right? 3-3 sigma tropic is a mechanism follow here. So first of all you have to do numbering, okay, because numbering is a very important. Without numbering you can't do sigmatropic. Okay, uh, so uh, so when you have to do a sigmatropic rearrangement, so try to first to give numbering and then you proceed. Okay, that's the best way to avoid the mistake. Okay, so now let's do the numbering here. So there is a 1 position, 2 position, 3 position. Now here is a 1 position, 2 position, 3 position. Now I I have been told you again and again the 3-3 sigma tropic means you have to join the 3-3 bond. You have to join the 3-3 bond, 3-3 bond, and break the 1-1 bond, and break the 1-1 bond, 1-1 bond simultaneously. Okay, because all the steps are going in the one step. Okay, it's a transition state. Simultaneously. Okay, so the main basic thing about 3-3 sigma tropic is just join the 3-3 bond and break the 1-1 bond. How we can do it? Let's see. So you have to do something like this. These 3 positions will attack on this bond, and then this double bond will gonna shift on here, and then this 1-1 bond will gonna break at here. Okay, and then you will find something like this. Here is a double bond, and here you will get a here double bond, and now you have here OH, and here is the alkyl group, R group is here, right? And yes, this is our enol form. Okay, so just do what tautomerization here, tautomerization, right? Then you will get in the keto form, right? So how it happened? So just take H2O, right? Just take H2O here. Okay, I am taking H2O here. So what happened? This lone pair will come back, and then this lone pair will take proton of this H2O molecule, and then you will find something like this. Here is a positive charge, and here something like this. Okay, because now it's happened now because we have done a protonation here by delocalizing the O lone pair, come back, and then this double bond will take a proton of this H2O, right? So now you will get a keto form. So, and now this OH minus, now this OH minus will take this proton, and you will get a keto form. Let me make here final product. You will get something like this. R here. Yes, this is our final product. Okay, this is our final product. Final product. Okay, this is all about the Oxy-Cope rearrangement. Why Why we are saying oxy? Because due to this is a hydroxyl group is attached, so that's why we are calling it just a oxy, right? uh, all the reactions of a cope rearrangement like Oxy-Cope, anionic Oxy-Cope, these are all the variety of a cope rearrangement. Okay, right? And yes, I have also told you the basic difference between the anionic Oxy-Cope and Oxy-Cope. So in the anionic Oxy-Cope, we take a low temperature, but in the case of a Oxy-Cope, we take a high temperature. 150 degrees Celsius to 260 degrees Celsius you can take. This is the reaction condition. Okay, so that's all about this reaction. Okay, I hope you all have understood very clear, very crystal and clear. And if you have understood, then please make sure like, share, and subscribe my channel, Chemistry Portal. Okay, because we are here discuss only organic chemistry, reaction mechanism, how the reaction is happening, what's happening in the reaction. Why not this? Why this only? Why the proton take? Why the base take proton this only? Why not this? All things, all doubts, silly doubts, silly mistakes. I tell you. Okay. So that's all about this reaction. So तब तक के लिए टाटा, bye bye, see you soon in the next episode series of name reaction, organic chemistry, organic name reaction series. Okay. Thank you for watching my video.